येस करा सुरू सर.
येस करा.
ओके सर, ठीक आहे, आपण सुरू करूया आता मग ना. It gives my pleasure to introduce today's guest lecturer, Dr. Avinash Kandekar sir. Sir is working as an assistant professor in the Department of Geography, Savitribai Phule University, Pune. Sir has a very bright and academic achievements. He has grabbed fourth position during the PG. He is a qualified state exam also and awarded a PhD in 2015. He is also recognized PhD guide since 2019. Also hydrological study, river morphology, degraded land studies, and application of geoinformatics is in modeling are the research interest area of Sir. Sir has published several research papers in various national and international journals. Sir has also completed a research project entitled Delineation and Management of the Wasteland in Panseth Catchment using Remote Sensing and GIS Technique, funded by the Savitribai Phule Pune University. Also, 2 students have already registered for the PhD under able guidance of Sir. Today, Sir will be guiding us on late Holland's environmental magnetic changes and monitoring, as well as the predictions of the deglaciation changes from 1988 to 2017 in Kanchenjunga, Sikkim and Nepal, Himalaya, implication to climate changes response. I am sure that today's session will be an interactive, informative, and enlightening for all of us. I request Sir to start the session. Thank you, Sir. Please start.
Okay. Thank you, Toy Fode sir. So to introduce myself. So just a minute, I will just. Okay, so is it visible, the whole slide to you?
Yes, sir.
It is visible, but I would suggest you to put it on the slide mode, sir. Slideshow mode. Sorry.
No, it is on slideshow mode only, sir. Because I can see the whole slide on.
No, sir.
No, sir.
Possibly there is a lag on my end then.
मला पण नाही दिसत. मला पण नाही.
नाही सर, इट इज नॉट ऑन स्लाइडशो मोड.
फुल स्क्रीन शेअर करावं लागेल.
नाही स्क्रीन शेअर केलेला आहे त्यांनी. स्क्रीन शेअर केलेला आहे.
स्क्रीन शेअर केलंय, फक्त स्लाइड मोड वरती नाहीये, स्लाइड शो वरती नाहीये.
नाही, हा आता माझ्याकडे तर दिसतोय सर. कारण
एकदा सर बॅक जाऊन परत.
ठीक आहे, मी परत एकदा
स्क्रीन शेअरिंग करताना सर युअर एंटायर स्क्रीन ते शेअर करा, म्हणजे ते व्यवस्थित दिसेल.
नाही, खाली तो जो बकेट सारखा जो आहे ना, ते शेअर केलेलं आहे. हा, आता दिसतोय का?
नाही सर, त्याच्यामध्ये 1-2 ऑप्शन आहेत सर. 1-2 ऑप्शन आहेत. तुम्ही ऍक्च्युली काय करणं अपेक्षित आहे की तुम्ही स्लाइड शो मोडला जाऊन मग परत ह्याला जर आलात, काय म्हणतो आपण याला, गुगल मीटला, तर देन वेन यू पुट अप युअर प्रेझेंटेशन फॉर प्रेझेंटिंग, मग तो तुम्हाला 2 पर्याय विचारतो आणि त्याच्यामध्ये यू कॅन सिलेक्ट स्लाइड शो मोड, असं आहे ते. तिथल्या तिथे तुम्ही केल्यावर ते आम्हाला दिसणार नाही सर.
ओके, म्हणजे परत त्या ह्याला जाऊन
नाहीतर याचा हे वाढवलात तरी चालेल, साईज वाढवा, तसंही करता येईल आपल्याला. दॅट्स अनदर ऑप्शन.
Okay, so I will check it first and then now it is full screen. Yes. Is visible?
No sir. Okay. No sir.
Okay, so
सर F5 प्रेस करून बघा.
नाही, ते सगळंच करून बघितलं.
नाही, एक काम करा, जाऊ दे सर. आता फक्त याची थोडी साईज वाढवा, जाऊ दे, ते राहू दे सर.
अजून वाढवू का?
F5 ने होत
थोडीशी वाढ. थोडस
नाही,
वाढवा.
नाही,
फाय पण केलं नाही होते फाय किंवा तो खालचा.
ती ही जास्त झाली सर, थोडी कमी करा आणि लेट अस स्टार्ट.
ओके. Is it okay?
ठीक आहे सर. येस.
Yes, sir.
Okay, so good afternoon all. I know that this is a quite complicated topic. So here in this my presentation in 1.5 hours. So I will present the two topics. So first one is the late Holocene environmental magnetic changes. Okay, so late Holocene, let me say you something about the Holocene. So right now we are in the Holocene period. So that is called it as an interglaciation period. Okay, so from last 11,700 years, so our Earth is in Holocene period. That is the interglaciation period. So we basically collected the the soil samples, sediment samples from the glacial lakes, and we performed the environmental magnetic change. So the next to our department, the geology department is there, and in which Professor Sangode, he is basically having this expertise in the mineral magnetism, or it is called as environmental magnetism. So this is a quite new branch to all the geographer. So one of my dissertation students, so he basically did this particular whole analysis part. His name is Shubham Gavane, and the next topic, that is monitoring as well as prediction of deglaciation changes from 1988 to 2017 in Kanchenjunga, Sikkim part and Nepal Himalaya part. So this is the contribution of next dissertation student, who was from MSc Geoinformatics, and both of them basically work on this Kanchenjunga. So let me first say about something about this particular thing. So in 2018 December and 2019 January, so we were there in Kanchenjunga part, that is Sikkim part, and we collected a sample. University provide us some funding of about 3,30,000 rupees, and the 7 students along with me were there, and out of that the 2 were basically did their dissertation work on this particular work. Okay, so Devne sir especially requested me to just so present the outcome of this particular expedition. Okay, so this expedition is the combination of the collecting the sample analysis, and this was the one of the eco expedition. So in 2019 Giri Premi, it is Pune based mountaineering club, so they basically organized this particular expedition, and this expedition was titled under the Kanchenjunga Eco Expedition. So the Eco Expedition in charge was so myself was the in charge of that Eco Expedition, and in the May 2019, so 11 climbers from our club, so they climbed Mount Kanchenjunga. So it is the 3rd highest mountain in the world. So this is the basically so much things involved in this particular the outcome, and for that matter I just basically introduce you people the background about this. Now I know that so all of you are the PhD student, so you can see the efforts and the contribution of this dissertation student, so that you come to know so what is expected from you as far as your PhD are concerned. Okay, so I think most of you know about this. So this particular is the international boundary in between India and Nepal, and here actually the Kanchenjunga peak is there, and this is basically the part of Sikkim, and this particular Sikkim part, it is called it as a Kangchenjunga National Park. Okay, so the spelling is quite different, but in local language, it is basically the Lapcha community is there, and so they basically refer this as a Kanchenjunga National Park, and it is the pride to all of our Indian that this is the one of the first mixed World Heritage site which was declared by UNESCO World Heritage List, and it is about 850 square kilometer area. Rest of the part of the Kanchenjunga, it is called it as a Kanchenjunga Conservation Area, which is there in the Nepal. So today I am presenting this, the first part, that is mineral magnetism. It is from this particular area, and the next part, that is the deglaciation changes, for which we selected this whole area. You can see over here the very few part of this Kanchenjunga, it is there in China. Okay, so this is the one of the area, okay, so which is basically located in the junction of the three countries, that is India, Nepal, and China. So these dotted lines showing that, so this is basically the route.
Hello, sir. Sir, slides are not moving.
Sorry to interrupt you, but slide can't change.
So now it can change?
No, sir.
No, sir.
Okay.
Yes, sir.
Yeah.
आता दिसते दुसरी स्लाइड?
हो
नाही,
दिसते.
सर आधी आली होती, पुन्हा
हो, दिसतंय.
पहिलीच आली.
3 नंबरला गेलात सर आता तुम्ही.
हा, पण
1 नंबर आली आता. 1 नंबर आली आता.
सर मी सजेस्ट करू का?
तुम्ही कशा सिलेक्ट करणार?
Yes,
नाही,
sir.
नाही.
खाली आहे.
स्क्रीन शेअर करताना एंटायर स्क्रीन शेअर करा सर, म्हणजे तुम्ही जे करणार आहे ते दिसेल. तुम्ही फक्त पीपीटी केलेली आहे, त्यामुळे तुम्ही चेंज केल्यावर इकडे दिसत नाही. स्क्रीन शेअरिंग प्रेझेंटच्या इथं स्क्रीन शेअर मध्ये एंटायर स्क्रीन करून बघा.
नाही तेच करतोय. आता दिसतेय का?
हो
नाही सर,
होतंय ना, झूम इन झूम आउट करताय सर.
हा,
ते होते.
नेक्स्ट दिसतेय ना?
हो सर.
हो 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 दिसते.
So I think this slide you people cannot able to see. एक मिनिट, बाकीचे तुमचा ऑडिओ बंद करा.
कांबळे सर, किशोर कांबळे सर, ऑडिओ बंद करा बरं तुमचा.
Okay, so this dotted lines, so representing, this is basically the route of the Goichala Pass. So this is somewhere here. So the base camp of this Kanchenjunga is there. Okay, so we reach up to this particular point, and we started. So road headed somewhere up to here in Yuksum, and this was the trek. We completed this trek in about 7 days. And the altitude gain is about 3,500 meters. Okay. Another team was basically went through this Fedang, and they reach up to this particular base camp, which is there in Nepal. Okay, so we don't have, or we basically cannot collect the sample which is associated with geography or geology. So we just keep this particular samples which were collected from this particular trek route. So this is basically the Kanchenjunga, third highest peak in the world, and so we reach up to somewhere over here, up to here. Okay, so that is the base camp of Kanchenjunga. For this particular base camp, which is there in Sikkim Himalaya, it is called it as a Goichala Trek or Goichala Pass. It is a base camp of Mount Kanchenjunga, Sikkim area. So from this Sikkim area, we basically were organized the 2 batches. About 32 participants were there. They completed this particular trek in 14 days. Okay, and in this particular expedition, we collected the sediment sample, rock samples, water sample, plant, diatoms, microbe samples, Here I am just presenting these sediment samples and rock sample output only. We especially collected the soil sample at a depth of up to 2 meters from these 4 glacial lakes, Sukha Pokhri, Lakshmi Pokhri, Samiti Lake and Salam Pokhri. And for this particular eco expedition, we have the association of Savitribai Phule Pune University, Agarkar Research Institute. They were basically studying the diatoms and the plant, that is a taxonomy. Praj Group, so they basically looking after that microbes. So these some of the slides. So it is basically the Kotak Lake in Yuksum at an altitude of 1736. It is the foothill region, and up to here, so we can basically have the road head. Then another lake, it was there at Soka. It is the en route. So now you can see this particular mountain range. You can see, so at the foothill of this mountain, so Yuksum is there. So we climbed about 1,500 up to this particular Soka. Then at 4,150 meter, this Lakshmi Pokhri is the one of the lake. Pokhri means in local language it is a lake. Okay, so this is Black Kabru. It is one of the well-known peak. It is located south of Kanchenjunga. So this is one of the holy lake, called it as a Lakshmi Pokhri. Okay, so the analysis part of this, we just keep only the Lam Pokhri, that is the 4th one glacial lake. So I am in today's lecture, I am just give it to you the sum of the outcome of that particular analysis. So this is basically the our team, so who were basically collected this sample. So we dig a trench. Normally the archaeology people, so they dig such kind of the trench. So we dig a trench, and you can see, so here the very coarser material is there in this particular Lakshmi Pokhri lake, and you can see here this is the black soil. So this black color, it represents the some of the at this particular phase when this sediment deposited, at that time in this particular area the luxuriant vegetation might be there. So we collected this sample for the palynological analysis. Okay, so I'm not going into detail about this. Next lake, it is the Samiti Lake. We are again collected sample from this from 2 pit. So you can see here, this is the Verglass. So this means it is a thin ice sheet. Okay, so normally up to 12 o'clock, so you can see this kind of the Verglass. Okay, normally in this particular type of the lake. So the height of this is the 4,327 meter. Okay, so it is about half in height as far as the Kanchenjunga are concerned. So these are the 2 pit location. So here it is A pit and B pit, and these 2 are actually that pit. This is A pit and this is B pit. So we dig up to the 2 meter. Okay, so at that harsh climatic condition, because normally the temperature goes up to the -5 even during the daytime. Okay, so one interesting thing is there. I know that, so most of you are from human geography background, but this is the one of the opportunity to you people to, you can see some of the upcoming branches of geomorphology. So here, I think some of you may heard about the Verb deposit, VERVE. Verb is the Lacusterian deposit, and you can see this series of lines are there. So in Verb deposit, what you can find, so during the summer season, when the snow melting is higher in extent, at that time, the coarser material deposited. So you can see over here, the coarser material over here. And in next season, when the winter is there, so fine sediment, that is a clay or silt, deposited above the coarser material. So you can see this one line represent coarse and fine material deposited one above other, and this we call it as a one verb year. So by this logic, so we can able to identify the how many years these deposits were there in that particular lake. Okay, so these pipes are inserted, and these pipes are wrapped. Okay, because for OSL dating, uh, we required this particular type of the precaution. Okay, so these samples could not be exposed to the sun. Okay, for that matter, we collected this like this only. This is the third most lake, Sukha Pokri. Okay, like the name itself. So the half meter pipe we can insert in it. Coursework lecture. SPच्या coursework. Okay, sorry. This is the third lake where we inserted the pipe. Okay, now this is the fourth lake. It is the name of this is Lam Pokri. So by name, मराठीमध्ये लांब आपण जसं म्हणतो. So by name itself, it is a extensive lake. So now only this much of the portion of the lake it is remaining. So I would like to say you some of the structure you can see over here. So this is basically the floodplain deposits. Here you can see this small river. It is meandering in nature. This particular portion which is blocked, this particular lake. So this is the end moraine. I think if you heard about the Roche Mountain, so this is the one feature. It is huge mountain. So this is the Roche Mountain, because might be about 1 lakh or 2 lakh or 1 million years back. So this was under the moving ice, and for that matter, it's having a gentle sloping region over here, and at this particular side, it having the steep escarpment. Okay, so we collected the samples from this particular lake, and for the first mineral magnetism, so we basically selected this Lam Pokri. So this is the study area, Lam Pokri. It is very small area, 0.1 square kilometer area, and you can see this is particularly the orientation of this particular lake. It is there in the Western Sikkim area. So aim of this particular study is to understand the response of sediment record to climate change in a Prekchu, that is a small river valley in the Sikkim Himalaya. Okay, so I know that most of you don't have the background of geomorphology, and for that matter, a very superficial, I would like to say the results which are there, which are more complicated one, because most of these analysis involves the geological part. And for that matter, whatever the very simplified concept which is there, which I am trying to show you over here, because after all we required or we want what is the outcome or what is the conclusions of this particular study. So our first objective was to study the climate change response of Lam Pokri lake sediment during the last Holocene period, and to ascertain the response from individual valley over a region that can leads to infer on a regional climate change and its connection with the adjoining region. Okay, because as I was shown you the 4 lake sample we collected, but this particular presentation in which we selected only the Lam Pokri. So other 3 lake samples we compare and we try our level best to publish it very soon. Okay, so this is basically that the Lam Pokri, and from this particular point we basically collected a sample. So you can see these 2 pipes. So this is 1 meter pipe and this is another 1 meter pipe. Okay, so this is in all the 2 meter pipe is there. We inserted this pipe into this particular portion, okay, up to the 2 meter. So we actually dig this particular, or we basically insert this pipe into this particular area, and so that it can basically preserve or it can basically keep that particular sample in that particular pipe. And after the collection of this pipe, so we basically wrapped both the side of this pipe. So you cannot imagine that like this. We basically have about 20 pipes. So one pipe, 1 meter pipe, weight is 5 kg. and after filling it, so it could be the about 10 kg. So only this pipe, about 10 pipes we collected, or we we collected the sample from the different glacial lakes, and about 10 pipes we collected from these 4 glacial lakes. Okay, so here also one pipe we inserted. So now whatever the result I am showing to you after this slide, it is from this particular pipe. Okay, so this after the cutting of this particular pipe, we can basically have this sample, okay, from that particular lake. Okay, so up to over here, this is basically the 1 meter pipe, and this is the another a half meter pipe, because this is a very muddy sediment. So whole pipe we couldn't basically get the sediment sample. Okay, after getting it up to in the Pune, okay, after that we can basically cut down this 2-inch pipe segment. So this particular pipe segment we preserve for the OSL dating. OSL is basically optically simulated lumination dating. So this particular portion and the below this, here also the 1/4 number samples are there. So both 2 and 4th number samples we could not basically process for mineral magnetism, but we basically try to get the dates of that particular sample, this one and this one, by using the OSL dating. The Physical Research Laboratory, Ahmedabad, it is basically the institution where you can basically get the OSL dates. Okay, so now whatever the samples are there, you can see over here, this is 1.1, 1.2, and likewise this is 3.1, 2, 3, 4, 5, up to this 3.42. म्हणजे थोडक्यात सांगायचं काय झालं तर हे 2 पाईप मधलं मटेरियल आहे, त्यातला हा जो पाईपचा पार्ट आहे हा आम्ही कट करून घेतला अंधारामध्ये लॅबोरेटरीमध्ये, कारण तो आम्हाला OSL डेटिंग साठी द्यायचा होता. आणि इथला खालचा पण पाईपचा जो तुकडा आहे या 4 नंबरचा, हा पण आम्ही OSL डेटिंग साठी दिलेला आहे. त्याचे रिझल्ट्स यायचे, त्याची स्टोरी मी तुम्हाला नंतर सांगू शकतो. Okay, so you can see in this particular pipe you can have a sand as well as the mud. Okay, and you can see over here it is basically having a curve nature. Okay, so that means up to the depth of 2 meters, these samples are basically deposited. Right now I don't know at what age, but most probably about 10 to 20,000 years ago these sediments were deposited in that particular lake. Okay, so it is very interesting story, okay, which we get actually the OSL dating samples. Then it is one of the very good contribution in this particular area. Okay, this is the methodology. I am not going into detail. Okay, so we basically, as I was told you, that mineral magnetism, it is basically the branch of geology, and in which the magnetic properties of a finer sediment we can able to identify. Okay, so for this, if you remember the continental drift theory, in which the paleomagnetism is one of the evidence. Okay, so along the both side of the mid-oceanic ridge, okay, so if you see the both side rock samples, so it can basically showing the same magnetic declination. Okay, so that means nowadays our today's magnetic field is there in a Baffin Island. It is north of Canada, and this Baffin Island is today's magnetic field. But if you remember the continental drift theory, so when before 200 million years ago, when the Pangea was there, at that time the magnetic field was near to the Gulf of Geneva, that is the today's westernmost part of Africa. So that means in this last 200 million years, from Gulf of Geneva to this Baffian Islands, so this our Earth magnetic field shifted their position. Okay, so like mid-oceanic ridges, in such kind of the sediment samples also, we can able to preserve the ferrous declination. So here you can see the study of magnetic properties of sediment to trace the changes in iron oxides, that is a ferrous, constitute being oxidative, reductive, detrital. Okay, so I'm not going into detail, but this particular magnetic particles in each small clay particle, it basically orient to that particular magnetic field or the magnetic north at that particular time. म्हणजे सर समजा एक 10,000 वर्षांपूर्वी त्या ठिकाणी तो पार्टिकल क्ले पार्टिकल जर तिथे स्टेबलाइज होत असताना त्याच्यातले जे आयन कंटेंट आहेत त्या आयन कंटेंट त्या वेळेसच्या मॅग्नेटिक नॉर्थला डिक्लाइन होतात. And that we can able to identify with the help of this particular branch, that is mineral magnetism. Okay, so these are the different parameters, magnetic parameters. About 10 parameters are there. So for that matter, I am not basically, so most of them basically having their own use. Okay, so for example, the saturated isothermal remnant magnetization, it is indicated of a volume concentration of magnetic minerals. Okay, so this whole basically exercise required about 2 month analysis in that particular magnetic lab of geology department, and these are the results. Okay, so each of these graph representing the result of this particular 10 different analysis. Okay, so this is basically the conclusion part. Okay, you can see this 1 2 3 4 5 6 7. So these are the different phases we can able to identify with the help of the result of mineral magnetism. Okay, so because the intermediate part I just keep over here, so that is more complicated and it is basically having a more geological background. Okay, so for that matter I skip this and directly the conclusion slides I just show it to you over here. So this is the peak 1, peak 2, peak 3, peak 4, peak 5, peak 6. Okay, so these peaks basically give us the idea about some of the phase, whether it is a warm phase or cold phase of that particular area. And you can see this from 4th onward. Okay, most of the samples it is showing a more or less same result. As I was told you, this is the uppermost part, 1.1, 1.2. This particular part we preserve for OSL dating, and this is 3.1 to 3.20. मगाशीच तुम्हाला ते दाखवले होते. So the lowermost section of this pipe, okay, in which this first, second and third section is there, so which basically shows us a very different scenario. So what is that? The mineral magnetic results show the variability in the sediment response to glacial valley depict the climate oscillation with regular cycle marked in 1, 2 and 3. Regular cycle means what? Here it is a regular fining upward cycle of sandy feces. Okay, in fluvial geomorphology, in sedimentology branch, okay, this particular terminology it is used, fining upward cycle. So it is this particular diagram, it is showing the fining upward. Fining upward means what? Here you can have the coarser material, most probably sandy particle or pebbles, and very fine particle you can see at the uppermost part. So in this first 3 section, which is located at the deepermost portion of this particular lake, which shows that it is a regular cycle which is showing over here. Regular means what? As I was told you, that word deposit, in which on a yearly basis we have the coarser sediment and we have the, followed by in winter we have the finer sediment. Again next season you have, in summer season, coarser sediment and finer sediment. So that is, we call it as a one work year. But here at a glance, for about 100 years or more than 100-year time span, so this basically showed us the mostly the coarser sediment is there at the bottom and finer sediment shows that this is basically the warmer period, whereas this is basically the colder period. Okay, so this is not a 1 year cycle, but it is about 100 or 1000 year cycle, which is basically showing that the fining upward cycle of the sandy feces changes with the irregular cycle upward, that is due to the lacustrine feces. So from this 4th up to this 8th, okay, so we have this particular scenario in which the lacustrine deposit, that is the whatever the sediment it is coming along with the moving water, it can store in the lake, and they basically from here up to here, so they can basically showing us the similar tendency, that is the lacustrine feces. So this zone 4 and upward showing the majority of the lacustrine species shows the relatively dynamic change in the mineral magnetism and other sediment parameters called irregular cycle here. So from here to here, this is basically the irregular cycle, whereas this is basically the regular cycle. So this mineral magnetism give us the idea that is the most probably this particular from 4th up to this particular uppermost part. So they are most probably showing the Holocene period scenario, because as I was told you, Holocene means it is an interglaciation period. Interglaciation period means what? In which the glacial start melting, and resultant of this you can see in the sediment deposition in the lake. म्हणजे थोडक्यात काय की होलोसिन मध्ये इंटरग्लेसिएशन पिरियड आहे की ज्याच्यामध्ये जास्त बर्फ वितळल्यानंतर ते जे पाणी वाहत येतं, त्या वाहत येणाऱ्या पाण्याबरोबर जे काही सेडिमेंट येतं ते ग्लेशियल लेक्स मध्ये डिपॉझिट होतं, आणि त्यामुळे जे ग्लेशियल किंवा लेकुस्टेरियन फेसिस जे आहेत हे आपल्याला या इथल्या वरच्या भागात दिसत आहेत, रादर दॅन ह्या खालच्या जे ते पार्ट आहेत. सो दिस मोस्ट प्रोबॅबली बिफोर होलोसिन पिरियड, इट रिप्रेझेंटिंग द बिफोर होलोसिन पिरियड. So once we get the OSL dates of this particular sample, as I was told you, so we preserve this sample and this sample for OSL dating. So suppose this sample of this particular lowermost section, if it is about 20,000 years back or 15,000 years back, so the story we can basically generate from here. So this particular result showing this particular section is the Holocene period sequences, whereas this is the prior to the Holocene period, that is in the late quaternary period deposits. Okay, so indicate the higher lake level in the response to the dramatic warming. Okay, so if you keenly observe or keenly hear this particular thing, so then you can come to know or you can able to understood. Okay, other thing we can also note it down here from this same diagram. The sand and its influx alternatively indicate the glacial advancement against the more warming condition marked by clay and such mineral magnetic concentration. So this sand you can see over here, higher sand concentration over here, higher sand concentration in this particular section and in prior area. So indicate that it is basically the more warmer period. It is approaching the more warmer period in this particular area. All peaks, so this P1 to P6 in a mineral magnetic concentration, therefore indicate the warm episode against their drops. So हा जो आहे हा वॉर्म एपिसोड दाखवतोय आणि नंतर परत तो ड्रॉप होतोय, परत वॉर्म एपिसोड दाखवतोय, परत तो ड्रॉप होतोय. So these 6 peaks we were identified. Almost all the parameter diagram so gives more precise condition of the climate warming. So here you can see this diagram is there. So this is the one of the indication of the climate change. So here you can see the more warming, you can see somewhere over here, and for that matter the sample showing the more peakedness, whereas here you can see the more downward condition. Okay, so I don't know how much you can able to understood out of this. So this is basically the instrument which were used by Professor Sangode in their laboratory. So I would like to say that is the Professor Sangode. Previously he was there in the Wadia Institute of Himalayan Geology. It is there in Dehradun, and he was a very pronounced scientist, and in his credit about 150 research papers are there. Out of that 150 papers, about 80 papers they were published from this particular mineral magnetism lab. Okay, so if you have some kind of this kind of the work, okay, so you can definitely approach Professor Sangwade. So this is basically the my student, dissertation student, Shubham Gavane. He basically analyzed this. As I was told you, these samples were optically stimulated dating, that is OSL dating we performed. So last year before lockdown, so Shubham were there in PRL, that is Physical Research Laboratory, and he basically prepared about 6 sample. So what we did in this OSL, so the whatever the samples it is there in that particular pipe, which is basically we procure from that glacial, that horizontal pipe I was shown it to you from the Samiti Lake. So that samples we collected for the OSL dating. So we separate out the feldspar and quartz out of that sample, and especially the quartz give us a dates of that particular sample. म्हणजे थोडक्यात काय आहे की आम्ही जे पाईप म्हणजे ते ट्रेंच खणली होती दाखवलं, त्याच्यामध्ये जे पाईप आतमधले इन्सर्ट केले होते ते आम्ही बाहेर काढल्यानंतर ते पॅक केले म्हणजे त्याला दोन्ही बाजूनी काळ्या रंगाची टेप लावली, आणि ते तिकडनं आणून आम्ही PRL मध्ये ज्यावेळेस नेले त्यावेळेस ते डार्क रूम मध्ये, म्हणजे ज्या ठिकाणी कुठलीही विजिबल वेव्ह फ्रिक्वेन्सी त्या ठिकाणी नाही येणार अशा डार्क रूम मध्ये ते दोन्ही साईडला 1-2 सेंटीमीटर कापले गेले, आणि त्यातला जो आतला जो सॅम्पल आहे त्याच्यामधले फेल्स्पर आणि क्वार्ट्ज हे सेपरेट आउट करतात लॅब मध्ये. त्यानंतर त्यांची जी OSL डेटिंगची जी एक फायनल जो इन्स्ट्रुमेंट आहे त्याच्यातनं तो सॅम्पल किंवा तो क्वार्ट्ज हा त्या ठिकाणी कधी डिपॉझिट झाला हे त्याचं एज तो दाखवतो. ओके, सो the PRL were charged about $500 for one sample. Okay, through collaboration they can basically accept our proposal, and most probably if next 2-3 months or in next 1 year we can get the result of this, and the further story we can basically able to generate after we can get this OSL dating sample. Okay, so along with this OSL dating, Shubham also did some other analysis by using the this Nikon microscope. It is transmitted light through the sediment sample. म्हणजे मातीचे कण जे आहेत, सेडिमेंट सँडचे कण जे आहेत ते मायक्रोस्कोप खाली बघितल्यानंतर त्याचं असं काहीतरी चित्र दिसतं. सो इट इज अ फोटो, इट इज द ब्रांच वी कॉल्ड इट ॲज अ पेट्रोग्राफी. सो दिस we can able to understood this is the opaque, this is biotite mica. Okay, rootlay, the horn blade, impurities, and this white color is nothing but it is the quartz. Okay, so as I was told you, 1.1 1.2 means it is the uppermost 2 samples. After that 2 number samples are there for OSL dating. From 3.1 up to 3.40 we can have the samples with us. and in which you can see about 80% to 85% part of this sample, it is belongs to the quartz. Other than quartz, biotite, mica, hornblende, feldspar, root clay impurities, it is there. By this particular analysis, we come to know in Lampokri, the petrographic analysis, as I was told, petrography means what? Over here it is written down. Petrography is a branch of petrology that focuses on detailed description of rock, the mineral content and textural relationship within the rock are described in detail. So that means what is the source of that particular sand, or this particular sand, which is basically keep it over here in slide. Okay, what is the source of it? So for that matter, we can collected the rock sample from this area, and we collected the soil samples from the glacial lakes. Okay, so it basically proved that all the sediment, it is derived from the nearby area, and from this particular gneiss and schist type of the metamorphic rock. So in Lampokri, the petrographic analysis shows that the sediment are sourced from gneiss and schist. So this combination, it is showing that it is basically belongs to the gneiss and schist type of the metamorphic rock, which comprises abundance of quartz, biotite, mica, and hornblende, with sub-angular and sub-rounded nature of grains, depict relative proximity of gneiss rock and the glacial fuel dominance nature of the sediment. That means these samples especially or carried out by the moving ice as well as the water, and which basically deposit this particular sediment in a short period of time. And for that matter, these samples or the particles are not angular, but it is subangular to the subrounded. म्हणजे थोडक्यात काय की जर तो अँग्युलर असता, तो जर पूर्णपणे राउंडेड असता तर काय की तो खूप जास्त प्रवास करून आलाय, आणि त्याच्यानंतर त्याच्यात प्रवास करताना त्याच्यामध्ये गोलाकार आकार त्याचा प्राप्त झालाय. So here we could not find this rounded particles. Why? Because it is driven from a nearby source area. Okay, so through this particular analysis, we come to know the source of that particular rock, that is gneiss and schist. Okay, so this is our team. As I was told you, so whatever the result we shown to you, so it is basically analyzed by the Shubham. This is one of my dissertation student. Likewise, this is the Gopal Bhalavi. He basically completed his dissertation on from Agarkar Institute based on climatic change by using the diatoms. She is basically the Rihanna Kisniwala. So she is also my another student. So she basically did her dissertation or completed her dissertation by using the sample of Lakshmi Pokhri, Samiti Lake, and Sukha Pokhri. Okay. So as I was told you, so this 7 student, this is 7 student, they were basically collected the sample for us. 1, 2, 3, 4, 5, 6, 7. So she is my wife. She is there in mathematics department. She was also along with us in this particular trek. My son was also there in this particular expedition. Okay, so this is the completion of the first part. Okay, I know that right now it is the 35 minutes remaining. Okay, so I will keep about 5 minutes for question answer session. So another topic which I am basically presenting over here, it was did by one of the other geoinformatics student. So the title of this is the monitoring and prediction of the deglaciation change. Deglaciation means it is melting. After the melting, so we called it as a deglaciation. So deglaciation changes from 1988 to 2017 in Kanchenjunga, Sikkim and Nepal area using remote sensing techniques. Okay, so for this whole area of Kanchenjunga, as I was told you, this is the Sikkim area part and this is the Nepal area part. we selected for this present study. Okay, it is very interesting thing. The objective was to map and monitor the changes in the spatial extent of glacial and glacial fuel geomorphic features using LIS-4, that is a 5.8 meter resolution imageries of the year 1988, 1996, 2004, 2008, 2017 of Kanchenjunga National Park, Sikkim, that is India, and Kanchenjunga Conservation Park, Nepal. Okay, so the 5 satellite images of winter season we selected. The image resolution was 5.8 meter, and by using this particular, we can able to predict the future projection. To predict the future projection of land use land cover change with special reference to glacier up to 2028 using multi-temporal classification method by Marco Chain Cellular Automata model. So by using 1998 and 2017 image, we can able to predict the 2028 scenario. Okay, so that will be the most probable scenario in this Kanchenjunga park, and so that was done with the help of the Marco Chain Cellular Automata model. Okay, so for this, the Landsat 5 TM data for this first 4 years and Landsat 8 OLI data, that is for 2017, we use. We also use the Aster 90 DM data for this. US Army topo sheet of 1962 we use for it. The same year Google Earth image. Okay, so we can basically use to identify the different glacial features. This is the methodology. Okay, and in which we can able to identify the accumulated area, ice exposed ablation area, debris cover ablation area, deglaciation area, glacial ice, and the glacial lakes and scarp faces. This is basically the accumulation area. I think, are you getting my point? So what we did for this particular, what we are basically proposed for this?
Yes, sir. Yes.
Yes, sir.
ओके, म्हणजे थोडक्यात सांगायचं तर काय आहे की आम्ही ह्यामध्ये एक विक्रांत बधे नावाचा जिओ इन्फॉर्मॅटिक्सचा स्टुडंट होता MSc पार्ट 2 चा. त्यांनी काय केलं, या 5 वेगवेगळ्या वर्षातल्या सॅटेलाइट इमेजेस घेतल्या 5.8 मीटर रेझोल्युशनच्या, आणि त्यांनी हे जे वेगवेगळे ग्लेशियल फीचर्स आहेत हे पूर्ण कांचनजंगा एरिया मधले त्यांनी आयडेंटिफाय केले. ग्राउंड ट्रुथिंग पण आम्ही काही याचं केलं होतं. त्यांनी सीडॅक मधले एक सायंटिस्ट आहेत विनय कुमार म्हणून, त्यांनी ऍक्च्युली ग्लॉफ मॉडेल वरती सिक्कीम मध्ये काम केलं होतं. त्यांच्याशी आम्ही अप्रोच झालो, तर त्यांच्याबरोबर आम्ही कोलॅबोरेशन याच्याबद्दल केलेलं आहे, आणि याच्यावरती माझा एक नुकताच स्प्रिंजर मध्ये एक बुक चॅप्टर ह्या पर्टिक्युलर टॉपिक वरती जो आता आपण बघतोय त्याच्यावरती पब्लिश होईल. सो I am trying my level best to show you the different features. Okay, so this is basically the backside mountain of Kanchenjunga. You can see over here, this is a huge ice. It is there. So as far as the geomorphological terminology are concerned, we call this as an accumulated area. That means when the snowfall occurs in this particular part, so in very short time period, so it can convert it into ice, and that is basically the accumulation area. You can see over here, this pink color, it is showing the scenario of latest one, 2017, and this is the oldest one, it is the 1988. So for this whole 5 years, we can able to see at what extent the accumulation area is basically changing in this particular region. Ice exposed area, so you can see this particular portion. Previously it was under the ice, but right now it is melt down, so it is called it as a ice exposed ablation area. So you can see over here the ablation area, it was very small in 1988. Okay, so after that in 2017 you can see a huge area it is under the ice exposed ablation area are concerned. Okay, so that means now in this last 30 years, 1988 to 2017, it is a 30-year time span. So in this 30-year time span, so you can see the huge area, it is shows the melting, and for that matter, you can see this particular changes over here. Debris cover ablation area. So this is basically the debris cover ablation area. This is nothing but it is the glacial moraine. Okay, it is a glacial valley, and this is, we call it as a lateral moraine. This is, we call it as a medial moraine. This is again the lateral moraine. Over here the medial moraine is there. Okay, so this we called it as a debris cover ablation area. So it basically showing the changes, that is the in 2017 the scenario you can see over here. So the extent of this is maximum. Okay, so this brown color, it is at the downside actually. So the maximum area it is there in the debris cover area. Next feature, that is the deglaciated valley. So deglaciated valley means what? The snout position. म्हणजे हिमनदीचं जे मुख असतं त्याला स्नाउट म्हटलं जातं. फॉर एक्झाम्पल, गोमुख इज द स्नाउट ऑफ भागीरथी ग्लेशियर. सो this is basically showing the snout position. So previously in 1988 the snout position is somewhere over here, okay, of that this Prekchu river, and now you can see in 2017 the snout position is somewhere over here. So this is actually the photograph of this particular area. So you can see this particular ridge. Okay, so this particular ridge is continue over here, and in between this the Prekchu river is there. So this is nothing but it is the end moraine, and end moraine basically showing the remnants of a previous snout position. म्हणजे पूर्वी जो ग्लेशियर होता तो इथपर्यंत होता, आणि आता ग्लेशियर हा मागे 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 गेला, आणि त्याच्यामुळे ही जी पूर्वीची जी एंड मोरेनची जागा आहे तशीच इथे दिसतेय. सो at this particular rate, okay, you can see over here the latitude and longitude. So this particular rate the glaciers are retreating backward, okay, in the recent past. The snout position you can see, actual snout position you can see over here. So in 1998 satellite image, the snout is somewhere over here, and now the snout is somewhere over here. So it is actually the snout of this Prekchu river. Okay, this is the snout of Prekchu river. So this is the debris cover, no doubt, but below this you can see this is the blackish color. So this is actually the ice. Okay, and this is the basically the moraine over here. So this is the consecutive years. So at an interval of 8 years, okay, so this this particular showing the snout position of this area. Glacial lakes, okay, as we already discussed this in previous one. This is the Black Kabru, and this is the Lakshmi Pokhri. So this we call it as a glacial lakes. Okay, so now as I was told you, or as if you remember, so this we call it as a circ or CWM. म्हणजे ग्लेशियर जे असतं हे असं साधारण असतं. ज्यावेळेस ग्लेशियर वितळतं, हे सगळं आईस जर वितळलं तर हा खालचा जो रॉक असतो त्याच्यात असं आराम खुर्ची सारखा तो एरिया असतो, आणि त्यामुळे हा जो इथला खड्डा आहे त्याच्यामध्ये ग्लेशियर पूर्ण वितळल्यानंतर इथे लेक तयार होतं. सो यू कॅन इमॅजिन द प्रिव्हियसली दिस होल एरिया अंडर द आईस, and this was the base of this particular cirque, and now the whole glacier melt down, and only the cirque lake or tarn we can call it as, so that we call it as a glacial lakes. Okay, so you can see the extent of glacial lake. So this particular glacial lake extension is somewhere up to here in 2017, but you can see So sorry, this is basically the in 1998, and now this whole area under the glacial lakes in 2017. म्हणजे याच्या इथपासून ते इथपर्यंत आता हे ग्लेशियल लेक आहे. So that means when the glacial melt down, so extent of glacial lake increases. Okay, so this particular slide is basically showing at what rate the glacial lakes increasing. So you can see up to here the glacial lakes increasing their the size, but in 2017 it is basically again shows the decreasing trend. These are the different glaciers. So about 104 glacial we can able to mark it out in this particular area. So somewhere over here the Kanchenjunga is there. So these all are the big glaciers. Okay, manually Vikrant digitize it with the help of satellite image, with the help of the some ground truth data, as well as with the help of Google Earth image, and we can able to identify about 104 glaciers in this particular area. After this, what he did, so he can basically work on this initially on this 2017 scenario, and then same glacial lakes shape file of different feature he can basically overlay on the different satellite image, for example in 2004 satellite image, and then manually he can change the polygon of each of the glacier. So it is very rigorous work he did it during his dissertation work, and he can able to identify this 5 different glacial features from this particular area. Along with this, these are the non-glacial classes like rocky barren area, scrub area, dense forest, snow-covered area. Okay, so under this snow-covered area, these all glacial features are there. So this is basically the one of the scenario in between 1988 to 2017. This is the basically the rate. Okay, he was find it out. So this mostly you can see this light green color. So this light green color showing that the glacier which shows the deglaciation effect or it shrink about 10%, 0 to 10%. So that means this maximum area, this green color, these are the glaciers which showing the 0 to 10% shrinkage because of the climate change. Okay, so you can see also the sum of this particular glacier, about 20% change it is there in this particular glacier. Or sorry, here it is a positive change you can see in this particular glacier, about 20% area increase in this particular glacier. But you can see this light blue color. So these are the glaciers which shows the shrinkage of about 30% to 20 to 30%. So that means 20 to 30% area shrink in this 30-year time span in these particular glaciers. Okay, so this is very, very alarming situation. So in a very short time period of 30 years, so in the first slide, we are basically talking about Holocene period, that is 11,700 years time span. And here in a very short time period, that is 30-year time span, about 20 to 30% of the glaciers, they shows the shrinkages, okay, in this particular area. So on that same rate might be in whole Himalayan region. So this shrinkage might be took place. So you can see this, the statistics, it is represented in the percentage wise change. Okay, so most of these glaciers shows the negative change. You can see the 20%, 40%, it is negative change. That means these glaciers are shrinking in their size. This is the basically the, not actually the data, this is the new glacier which basically mark out in some one area, that is 0 104 glacier. You can see over here this 104, it is a very small glacier. So it is basically come out, or it is basically separate out from the adjacent glacier, and for that matter it is showing the positive change, but this is not actually the positive change. So almost all except these two, okay, showing the negative change. That is the glacier showing the melting. Okay, over here you can see this accumulation area percent change you can see in minus. So that means it is basically so its area, it is basically decreasing nature. But on the contrary, you can see the glacial lakes, you can see the 23%, okay, of the glacial lakes, it shows the increasing trend. Deglaciation area, it is showing the 20% increase. Debris cover 10%, scarp phase 11%. So they basically shows the extension of this particular area as compared to this. So that means whatever the area it is shrinking over here, sorry, increasing over here, sorry, increasing over here, it is showing the negative change in this particular two area, accumulation area and ice exposed area. So another good thing we can did it for as far as the second objective are concerned, that is actually by using the Markov chain analysis, we can able to predict the scenario for the next time period. Okay, what we actually pixel to pixel, as I was told you, all of them are basically these 4 satellite image. So pixel to pixel transition matrix we can able to perform by using the Markov chain. So I just give it to you the idea what we did it for this. So by using 1988 and 1996 image, we can able to simulate the scenario for 2004. Okay, so this is the simulated scenario for 2004 by using 1998 and 1996 satellite image. So I just give it to you the one example. Suppose you consider this is 1988 image, this is 1996 image. Okay, so here one pixel is there, we call this as a X pixel. Okay, suppose some pixel is here in this particular part. So we consider 1988 same pixel, 1996 same pixel. What is its transition? Whether it is same or it can change from accumulation area to ice exposed ablation area or debris cover ablation area. And by using the scenario of both of this, by using this Markov chain analysis, we can able to predict or simulate the 2004 scenario for that same pixel. So this is the simulated image by using 1998 and 1996. So simulated image of 2004, and we actually use the 2004 satellite image for actual classification. So this is the actual land use land cover classification of 2004 image, and this is a simulated image. मी एकदा परत एकदा मराठीत सांगतो, थोडं आपल्याला कन्फ्यूज होईल हे नक्की काय केलेलं आहे. म्हणजे ह्याच्यामध्ये लाखो पिक्सल्स आहेत, बरोबर. तर ह्या प्रत्येक पिक्सलचं म्हणजे 1998 मध्ये समजा हा इथला कॉर्नरचा पिक्सल घेतला तर तो 1996 ला त्या पिक्सल कशामध्ये रूपांतर झालेलं आहे. तर याच्यावरनं आपण 2004 चा त्या पिक्सलचं ट्रान्झिशन कशात होईल हे मार्कव चेन अनालिसिसने आपण प्रिडिक्ट करू शकतो. तर ते जे प्रिडिक्शन आहे हे सिम्युलेटेड इमेज मध्ये आपल्याला दिसतंय. आणि ऍक्च्युअल इमेज म्हणजे काय, ऍक्च्युअल 2004 ची लिस्ट 4 इमेज घेतली आणि त्याचं क्लासिफिकेशन केलं आणि ती ही ऍक्च्युअली इमेज आहे. ठीक आहे. सो वी डिड दिस फॉर द व्हॅलिडेशन. व्हॅलिडेशन म्हणजे काय की आपण किती ऍक्युरेट आहोत, म्हणजे हे ऍक्च्युअल इमेजचं क्लासिफिकेशन आहे आणि हे सिम्युलेटेड जे आहे हे याच्या किती जवळ आहे हे आम्ही चेक केलं. So this is actually the scenario. Okay, in between this is basically showing the simulated scenario and this is the actual scenario. So you can see over here the accumulation area, ablation, ice exposed ablation area, debris cover area, deglaciated area, glacial lakes. It is showing the no change in the simulated and actual image. So this Markov chain analysis is very good, okay, for the future prediction. Okay, म्हणजे या ठिकाणी आपण 2004 च्या इमेज साठी की जी नोन इमेज आहे आपल्याला त्याच्यासाठी केलं. Then we can perform the same methodology by using 1988 and 2017 image, and we can able to predict the simulated image for 2028. Okay, so this is the basically the scenario. Most probably in 2028, if the same trend it was there from 1988 to 2017, we can definitely get this is the scenario of the Kanchenjunga National Park and Conservation Area of the Himalayas. Okay, so these are the conclusions. So glaciers of Kanchenjunga area have undergo the negative area change, that is a glacial retreat in 1988 to 2018, that is for about 29 years. Total glacier area decreases by 43.5 square kilometer area. Okay, so out of that, so I'm talking about that 104 glaciers, which basically all of them combinedly showing the decrease in the glacial area by 43.5 square kilometer area. It also means that the rate of deglaciation noted in this study was 1.5 square kilometer per year. म्हणजे ह्याला डिवायडेड बाय 29 केलं की 1.50. So per year this much of area retreat back or deglaciated in this particular area. So this is the average per year rate of deglaciation, or 3.45% per year area it is deglaciated in this particular region. In this 29 years, accumulated area decreased by 49, ice exposed by 10, debris cover by 16.2, glacial lakes increased by 0.75 square kilometer area. Accumulated and ice exposed ablation area shows the retreat of 6.66 and 0.44 respectively by 2020, whereas it will be 2.21 and 2.43 respectively by 2028. So this is the one of the interesting result of this particular exercise. Okay, so now this is over as far as this particular the two study are concerned. So as I was told you, so we reach up to this particular the base camp of Kanchenjunga. So this is actually the Kanchenjunga. This is the last point, which is called it as a Goichala viewpoint 1. The height you can see over here 4,601 meter. So this is whole team of who basically reach up to that Zongri top, which is basically the height is 4,100. So after the completion of this particular trek up to this highest point, okay, we reach up to this particular, somewhere you can see over here. So this is basically the Samiti Lake, and in this particular valley we have the Lampokri Lake. So after the completion of this trek, all other were come down, and along with my student, we basically collected sample from this nearby area. So here you can see this all of us basically wearing this feather jacket, okay, because at this particular altitude the temperature at morning, so it was about -5 degrees Celsius. These are some of the photographs we take out from our journey. This is Prekchu River. Every morning the smaller streams, it is basically frozen condition, and we can see this very fantastic scene over there. This is the Mount Pandim. So the golden cap you can see over here. This is panoramic view of Kanchenjunga and adjacent peaks. You can see this is the Black Kabru. ओके, त्याच्या जवळ जे समिती लक्ष्मी पोखरी होता तो इथं आहे. सो दिस इज द होल every morning and every evening we can see this very fantastic view. It is a golden cap on Mount Pandim. So here it is a Kanchenjunga. So this is the Prekchu River, one of the panoramic view. This is a temperature inversion we can call in climatology. So you can see definitely over here. So most of the time the clouds you can see here, the clouds are here. So we were above the clouds most of the time. These are the some of the panoramic photograph. This is Mount Kanchenjunga. It is the 180-degree photograph. The red panda, it is very rare species. We can basically have a photograph of this red panda. That is a state animal of Sikkim. This is a very rare animal, that is blue sheep. त्याचा कस्तुरी मृग जो आपण म्हणतो, तर हे ते कस्तुरी मृग आहेत. So local language it is called it as a blue sheep. This is the Soka. You can see again the golden cap over here. And this is Mount Pandim from Soka. Thank you. If you have any questions, so you can ask me.
Yes, participants, you can connect to the topic. You can ask your questions.
I know that some of the things you could not able to understood, but if you have any interest, you can ask me anytime.
Sir, just out of interest, what was the cost beyond the university aid that you got, and how did you manage that?
Basically, the whole journey, our student basically most of them are from the rural area, so they cannot basically afford this.
Exactly.
So initially we basically take some amount, about 3,000 rupees for taking tickets, okay, railway tickets. आणि मी तुम्हाला सांगू इच्छितो की आमच्या मुलांनी कुठे आम्ही पोर्टर बिल्टर कुठल्याही स्टेशनवरती आम्ही घेतलं नाही. आमचं आम्ही सामान हे केलं. म्हणजे साधारण 350 किलो हे फक्त त्या पाईपचंच वजन होतं. तर पैसे कमी असल्यामुळे ते, कारण युनिव्हर्सिटीने आधी पैसे दिलेच नाही. म्हणजे आम्ही जाऊन जानेवारीमध्ये आणि मार्च एंडला आम्हाला ते पैसे मिळाले. म्हणजे हे जर मिळाले नसते तर तो सगळा भुर्दंड मलाच भरावा लागला असता. पण इंटरेस्ट होता. सो दिस इज द फर्स्ट टाइम when my hobby, so most of you know about I am basically the secretary and now I am a member of Giri Premi Club. So this is the first time when I basically use my hobby or my trekking habit for collecting the samples and analyze it for as far as the geomorphology and geology are concerned. So म्हणजे इनिशियली तरी मीच सगळे पैसे टाकले होते आणि नंतर युनिव्हर्सिटीकडनं मिळाल्यानंतर ते मग रिइम्बर्स करून घेतले होते. स्टुडंटला बिलकुल हे पडले नाही असं नाही झालं. साधारण 3,000 ते 5,000 रुपये प्रत्येकाला हे झाले, कारण त्यासाठी लागणारे जे इक्विपमेंट आहे, शूज वगैरे जे प्रत्येकाचे घ्यावे लागले. बट त्याच्या आधी आम्ही याच्यासाठी खूप जास्त ट्रेक पण केले होते. म्हणजे जवळजवळ 17च्या आसपास आम्ही ट्रेक केले होते या मुलांचं फिजिकल फिटनेस हे करण्यासाठी.
ट्रेनिंग. ओके.
म्हणजे प्रियंका हिरे सरांची मुलगी पण ह्याच्यात होती, पण ती इकडे येऊ शकली नाही कारण त्या फिजिकल फिटनेसच्या ट्रेनिंग मध्ये तिला कळलं की आपण एवढं नाही काही स्ट्रेनस करू शकत.
ओके.
तर म्हणजे आउट ऑफ 7 स्टुडंट, सो 5 reach up to the Lampokri. So Lampokri is the highest place in this our trek. So it is one of the interesting and basically memorizing experience. आणि काय इंटरेस्ट आहे शेवटी, त्यामुळे
अगदी
केलं.
काय एलिव्हेशनला गेले होते सर तुम्ही मॅक्सिमम मुलं सगळे?
4,300 मीटरला ते गेले होते. आणि जे आपण याचा जो बघितला, आम्ही गोयचाला शेवटच्या पॉइंटला गेलो होतो तिथं 4600 होतं. पण सॅम्पल कलेक्शन किंवा त्या ठिकाणी आम्ही जे ट्रेंचेस खणले ते साधारण 4000 मीटरच्या ह्याच्यात, म्हणजे 3 ते 4 वेळा कुदळ मारली की त्यानंतर आम्ही दुसऱ्याला कुदळ द्यायचो किंवा फावडं मारल्यानंतर ते फावडं दुसऱ्याला द्यायचो, कारण इतकं तिथे ऑक्सिजन लेवल कमी असल्यामुळे दमाईत लावायचं. आणि आम्ही तिथे पोर्टर किंवा जे तिथले हेल्पर आम्ही घेऊ शकत नव्हतो, कारण तेवढे पैसेच नव्हते, कारण माहित नव्हतं की युनिव्हर्सिटी देईल का नाही देणार ते. त्यामुळे ते स्टुडंटला पण माहिती होतं आणि म्हणून त्यांनी पण सुरुवातीपासूनच या सगळ्या गोष्टी हे केल्या. पण त्याच्यातनं ती मुलं अजूनही टचमध्ये आहेत, कारण याच्यातनं आउटपुट काय मिळालं हे रिसर्चचं तर आहेच आहे, पण त्या जर्नीला खूप महत्व होता. म्हणजे त्यातला एक आणि एक क्षण आम्ही तो जगलो, त्यामुळे ते खूप असे छान मेमरीज आहेत. सो थँक्यू व्हेरी मच सो गिव्हिंग मी द ऑपॉर्च्युनिटी टू प्रेझेंट माय this expedition outcome, okay, in front of the PhD students.
Yes, sir. Thank you to you. You have brought so much of information from there. Participants, if you have any questions, you can still go on and ask him the questions. याचं फ्युचर आता अजून काय काय तुमचं करायचं प्लॅन आहे सर?
नाही, आता मी म्हणलं ना, आम्ही म्हणजे शुभम गव्हाणे मागच्या फेब्रुवारीमध्ये 2000 म्हणजे जेव्हा लॉकडाऊन लागलं त्याच्या आधी जाऊन त्यांनी सॅम्पल प्रिपरेशन करून आलेलं आहे PRL मधनं.
ओके.
एक नवीन चव्हाण म्हणून एक आहेत, तर त्यांच्या बरोबर त्यांनी मी सांगितलं तसं $500 हे पर सॅम्पलला ते PRL
ऐकत होतो. येस.
तर त्यामुळे ते आपल्याला कोलॅबरेशन मधनच त्यांनी हे केलेलं आहे आणि त्यांचं नाव त्याच्यात असेल त्या पब्लिकेशन मध्ये. ते रिझल्ट एकदा आल्यानंतर आम्हाला त्याचे डेट्स कळतील आणि ते डेट्स आल्यानंतर हे मिनरल मॅग्नेटिझम आणि याचे रिझल्ट आपण वापरू शकतो. याच्या बरोबर पण अजून पण खूप आहे, म्हणजे जसं आगरकर इन्स्टिट्यूट मध्ये डायटोम्स स्टडी केले गेले, ते पण त्याचे डेट्स आले तर त्याचा एक चांगला पेपर होऊ शकेल. डायटोम्स म्हणजे अलगी एका प्रकारची असते, म्हणजे जगातला साधारण 20 ते 25% ऑक्सिजन जो असतो हा डायटोम्स जनरेट करतं. समुद्रात असतात, नदीत असतात, दगडावरती असतात, तर त्या रिलेटेड एकाने केलेलं आहे. हेच सेम सॅम्पलचे आपण नंबरिंग बघितले, तेच प्राज इन्स्टिट्यूट म्हणून आहे, प्राज ग्रुप जो आहे तिथे यास्मिन मिर्झा नावाच्या एक डॉक्टर आहेत, तर त्यांनी याचे मायक्रोब्स केलेले आहेत, म्हणजे त्याचं DNA लेवलला त्यांनी हे केलेलं आहे, म्हणजे सरफेसवरती आणि जे 2 मीटरचा खालचा सगळ्यात पाईप होता त्याच्यातले त्यांनी त्यामध्ये असलेले अलगी, त्यामध्ये असलेले फंजाय आणि त्यामध्ये असलेले बॅक्टेरियाज, ते याचं त्यांनी मायक्रोबायोलॉजीचं क्लासिफिकेशन केलेलं आहे. याचे एकदा डेट्स आले की ते पण एक चांगला कोलॅबोरेटिव्ह असा रिसर्च होईल. त्यांच्याकडे एक PhD स्टुडंट आहे, तिने हा टॉपिक घेतलेला आहे मायक्रोबायोलॉजीसाठी. तर तसं आहे, बघू फ्युचर. अजून याच्यावरती आता एक माझा फक्त एक जो बुक चॅप्टर म्हणलो तो आहे, याच्यावरती पेपर होईल, पण सांगोडे सरांबरोबर काम करत त्यामुळे हे कुठेही लगेच छापलं जाईल, पण ते म्हणतात की ते डेट्स येत नाही तोपर्यंत आपण नाही छापायचं हे. कारण सिक्कीम एरिया जो आहे हा युनेस्को हेरिटेज साईट आहे, त्यामुळे तिथे ते आर्टिकल 307 जो आहे F तिथे आहे, त्यामुळे तिथे बरेच फॉरेनर्स तिकडे येत नाहीत या असल्या प्रकारच्या अभ्यासासाठी. नेपाळमध्ये जातात किंवा जम्मू काश्मीरमध्ये खूप आपला स्टडी आहे. हा जर स्टडी इथनं जर रिझल्ट आम्हाला जर अपेक्षित जर मिळाले, म्हणजे 20,000 किंवा 30-50,000 वर्षापूर्वीचं सॅम्पल्स जर डेट्स याला मिळाली, तर हा एक चांगलं कॉन्ट्रीब्युशन होईल की सिक्कीम एरिया मधलं अशा प्रकारचा अभ्यास झालेला नाही,
पहिलंच काम असेल
किंवा म्हणजे ईस्टर्न हिमालय मधलं काम नाहीये असं कुठलंच. चायनीज पार्ट मध्ये काही काम आहे याच्यावरती, त्याचे डेट्स वगैरे आहेत, पण या इथल्या पार्ट मधले कुठलेही डेट्स नाहीयेत.
कॉन्ट्रीब्युशन राहील, चांगलं
कॉन्ट्रीब्युशन होईल. हा, म्हणजे शेवटी आपण काय शिक्षक आहोत, आपण आपला पगार मिळणारे, पण सॅटिस्फॅक्शन जे आहे या कामातनं खूप मिळालं.
अगदी बरोबर. थँक्यू सर.
ओके, थँक्यू.
फार छान होती सर.
ओके, थँक्यू सर. थँक्यू फॉर गिव्हिंग मी अपॉर्च्युनिटी.
ओके.
वोट ऑफ थँक्स.
ओके सर. हा, ओके सर. ओके यार. Thank you, sir, from the bottom of my heart, Dr. Avinash Kandekar, sir. Your skill will to explain the different and difficult topic, different and to both the difficult topics in the search of simple way. Today you open the whole of thoughts in everyone's mind. We were all the highly enlightened with our knowledge. I thank you sir, so much and a wonderful session. I would like to also thank you for organizing committee for giving this opportunity to me. Thank you one and all, and thank you very much. Thank you.
Thank you.